NO2 is a brown gas found in photochemical smoke. NO2 forms from the reaction of NO and O2 in the atmosphere. Suggest a method to measure the rate of reaction. So let's look at the first part of the question. What we have, there is a color given, so brown gas. So we can use colorimetry. So colorimetry, we can measure the color change using colorimeter. To measure the intensity of color change. Measure the intensity of color change with time. Color change with time. We don't need to write that much. Just saying colorimetry, color change, measure color change using colorimeter. That will give us 1 mark. Let's move to the next part of the question. Determine the order of reaction. So order of reaction for each reactant and the rate expression. So we have been given experimental data and asked to find out the order of reaction with respect to each of the reactant and then write the rate expression. We can compare experiment 1 and 2 where the concentration of NO is kept the constant and concentration of O is changed. So the concentration of O2 is doubled, so it changed a factor of 2. And if we look at the initial rate, so rate also becomes doubled. So we can say order of reaction with respect to oxygen is first order. So with respect to O2 is first order. Now we can compare experiment 2 and 3 where the concentration of oxygen is kept constant and the concentration of NO, nitrogen oxide, is doubled. And if we look, the initial rate that is changed by a factor of 4, so it's quadruple. So we can say with respect to NO is second order, so the molar concentration of NO to the square. So rate will be equal to K, rate constant, lowercase k, molar concentration of NO square, molar concentration of O2. So second order with respect to NO, first order with respect to oxygen, and overall third order. Let's move to the next part of the question. So determine the value and the units of rate constant using data from experiment 3. So let's rearrange the equation for K. So K will be equal to rate over NO square, times by oxygen, molar concentration of oxygen. Let's substitute the values. So the rate for experiment 3 is 0.227 divided by molar concentration of NO is 0.040 square times by 0.020. If I solve this, that gives me 7093.8. Or we can write down in standard form, so 7.094 times 10 to the power 3. Let's derive the units. So the units of rate are mole per dm cube per second. So mole per dm cube per second. So divided by units of concentration is mole per dm cube. So mole per dm cube square times by mole per dm cube. So mole per dm cube will cancel with this mole per dm cube, and we will have mole minus 2 dm6 per second. So this is the way we can get 1 mark for units and 1 mark for rate constant. Let's move to the next part of the question. NO2 can form complexes with metals such as copper and magnesium. Describe the bonding within the complex and the role of NO2 in acid-base terms. So the type of bonding will be coordinate covalent. So within the complex there will be a coordinate covalent bond and also covalent bond. And role of NO2 will be ligand, but in terms of acid base it will be a Lewis base. So Lewis base is electron pair donor. The Winkler method is used to find the concentration of oxygen in water. 200 centimeter cube of water was taken from a river and analyzed using this method. The reaction taking place are summarized. So there are 3 steps given. This method is used to find the BOD of a river water. So the first question is identify. So we need to write down which species, identify, and then with the reason, the species which is reduced in step 1. So reduction is gain of electron, reduction is decrease in oxidation number. So let's assign oxidation number. I can straight away see in step 1 oxygen is an element, so 0. On the product side is -2, in water is also -2. So I will write oxygen is a species, oxygen, O2. And for the reason I will write 0 to -2. So decrease in oxidation number, decrease in oxidation number is called reduction. Decrease in oxidation number, 0 to -2. So that is the reason. That will give us 1 mark straight away. Let's move to the next part of the question. So 4.8 times 10 to the power -3 moles of iodide were formed in step 3. Determine the number of moles of oxygen in the water sample. So let's look at the ratio first. So if we can see in step number 3, so the ratio between iodide ions to iodine is 2:1. So straight away we can find out the moles of iodine first. So I2 Ni2 will be equal to 4.8 times 10 to the power -3 divided by 2. So that will give me straight away 2.4 times 10 to the power -3 moles of iodine. Now, next we need to find out the moles of oxygen, so we need to look for the molar ratio. So if we go back to step 1, so 1 mole of oxygen produce 2 moles of MnO2. So oxygen O2 to MnO2. So the ratio is 1 into 2. So in the second step, we have 1 mole of MnO2, and that gives us 1 mole of iodine. So either we can multiply equation 2 by 2 to simplify things. So if we multiply with 2, so you can see 2 moles of 2MnO2 will give us 2 moles of iodine. So the ratio between iodine to oxygen is 2 into 1. So I2 to O2 is 2 into 1. So the moles of oxygen NaO2 will be equal to 2.4 times by 10 to the power minus 3 divided by 2. So we'll have moles of oxygen 1.2 times 10 to the power minus 3 moles of oxygen. Let's move to the next part of the question. So calculate the concentration of oxygen in gram per dm cube. So concentration in gram per dm cube. So let's find out the mass of oxygen in that 200 centimeter cube of sample. So mass will be equal to moles times by molar mass. So the moles of oxygen are 1.2 times 10 to the power minus 3. Molar mass of oxygen is 32.00. If I solve this, that will give me 0.0384 gram of oxygen. So next is we need to find the concentration in gram per dm cube. So that will be equal to mass over volume. Mass is 0.0384 and volume is 200 centimeter cube. We can convert that into dm cube. So that will be 0.200. If I solve this, that will give me 0.192 gram per dm cube. A Voltaic cell is made using a nickel electrode Ni solid, a silver electrode Ag solid, and solutions of nickel nitrate and silver nitrate. A. Label the diagram with electrodes. Label the diagram with electrodes. That's a key thing. And then electrolytes, and then direction of electrons. Use section 24 or 25 data booklet. In new specification, we have section 19, and we have been given the E values of different half cells. If you look in that data booklet, so nickel has E value of, nickel half cell has a value of minus 0.26 for nickel half cell. And for silver half cell, so the E value is plus 0.80 volt. So Voltaic cell is a cell that converts chemical energy into electrical energy and is spontaneous, delta G less than 0. So oxidation takes place at anode, and looking at the value of each cell, nickel need to get oxidized. So hence we can write here nickel solid. So this is nickel electrode, and oxidation takes place at anode. Anode will be negatively charged here. So electron, they will leave through here. So this will be the direction of electrons, and they will move towards cathode. So hence cathode is made up of silver solid. Cathode is where reduction takes place. And we have electrolytes now. So at anode, nickel nitrate, NiNO3 twice aqueous is used as a electrolyte. And on silver half cell, silver nitrate aqueous AgNO3 aqueous is used as a electrolyte. So looking at the E values, the most negative need to get oxidized because it's a better reducing agent, and the most positive need to get reduced because is a better oxidizing agent. So nickel is in this case our anode and silver solid is our cathode. Let's move to the next part of the question. Outline why a salt bridge must be included in to connect the two half cells. So salt bridge is made up of usually a filter paper soaked in potassium chloride. So the function of salt bridge is to complete the circuit. So to complete the circuit, and that allows the ions to flow. So ions to flow into or out of half cell to maintain the balance of charges. Balance of charges. Okay. So outline. So the first, to complete the circuit, the ions to flow into or out of the half cell to maintain the balance of charges is a function of salt bridge. And a salt bridge is usually made up of a filter paper soaked in potassium chloride.